Hey scholars, it's good to be back with you, and I want to do another guitar video today. I've gotten some questions about how guitar truss rods work, so that seems like a pretty good idea for a video. Let's do that. I've got my guitar here, I've got a bunch of them in here, but here's one of them. So I can do this without dropping that. There we go. This is a Fender Squier Telecaster. This is an inexpensive kind of student guitar that's a pretty good buy. I like them quite a lot. I've made some modifications to this one. But it's got a feature on it that I think is familiar to anybody who's ever looked at a guitar. See that little hole up there in the end of the headstock? This thing here is called the headstock. That little hole in there, if you look in there, there's a little nut in there, socket nut that you can turn. What's that for? Well, that's how you can adjust the truss rod. This guitar has a metal rod going down the neck. In fact, on some Fender guitars, they've actually got a dark piece of wood down there that everybody calls a skunk stripe. That's to cover up the truss rod. That's how the truss rod goes in. On this one, the neck and the fretboard up here are two different pieces of wood, so the truss rod goes in before these pieces are glued together. All right, so what's a truss rod do? Well, it's designed to straighten the neck out, stiffen it and straighten it out a little bit. And here's pretty much what's going on. If you look at how a guitar neck works, and I'm going to draw just a kind of conceptual one here, and here's where it hooks onto the guitar, whether it's electric or acoustic, doesn't matter, right? The strings are up here. They go over a saddle and they're going that way. They actually hook to the sound post that way, the tuner post that way. But there's tension in these strings. Now the tension in English units is anywhere from 100 to 200 pounds if you've got a 12 string. So it's like 400 or 500 newtons, something like that. 50 kilograms if you want to look at it that way. Those are the absolute lowest numbers. But the point is there's substantial tension along this neck, and the tension is above the elastic axis of the neck. You know, the bending center, the elastic axis of the neck is down there somewhere, and the tension is above that line. So what we can do is, using basic statics, we can replace that force with this force and a moment. Okay, moment applied to the end of the neck means there's got to be a reaction force and a reaction moment at that end of the neck, or else the neck's going to move. Well, this is a static problem, so the neck isn't going to move. And what this means is the neck will bow. It'll actually go up at the ends or down in the middle, however you prefer to look at it, so that under tension, the neck is going to do that. Now this is very exaggerated. It's a typical neck bow is on the order of 1 millimeter, 2 millimeters of neck bow, so 1/10 of an inch or so is an awful lot. Okay, when we talk about taking bow out of necks and straightening necks out, we're talking about very, very small numbers here, fractions of a millimeter. If you want to think about it in inches, 10,000ths of an inch is, you know, that's kind of the world we're in right now. So without some sort of stiffener in here, the neck's going to do that. And unless you're really, really careful about how you build it, you don't necessarily know how much of this you're going to get, because you don't know what kind of strings the player's going to put on it. You don't know how they're going to tune it. There's all kinds of things that you don't really have control over. So what manufacturers do is they put a truss rod in there to help counteract that effect. Alrighty? And so there's one of them. Here's a little, this is kind of an odd little guitar. It's a little travel guitar called a Washburn Rover. And this is a cool little guitar. These are a lot of fun. I recommend these. If you look in any acoustic guitar, you have this one just because it's easy to hold up in front of the camera. But right in there, there's that same little end of a nut like you saw in the other guitar. It's in there, and if you have an Allen wrench, you can stick it in there and you can turn that nut. Well, what does that do? That adjusts the truss rod. Okay, now if we're going to understand truss rods, we got to get an overall picture of it here. So the big idea is, number one, you want to reinforce the neck, and number two, you want to be able to adjust it to accommodate the conditions it's being played under and the tastes of the player, things like that. So we need some kind of structure in there, and it needs to be adjustable. It would be nice if it was adjustable. They aren't all. So let's characterize sort of the field of truss rods first. So we're going to have non-adjustable, we'll call those fixed. and adjustable. All right, those are two kinds. Now, if they're fixed, what a fixed truss rod is, it's really just a bar in there that's glued in place or something held in there somehow that stiffens the neck, but it's not adjustable. It just increases the bending stiffness of the neck. The elastic modulus of wood is low. The elastic modulus of steel may be 30 times the elastic modulus of wood. So all other things being equal, a piece of steel is 30 times stiffer than a piece of wood the same size and shape. Now if you want to put a graphite truss rod in there, it's somewhere in the middle, but it's easily going to be 10 or 20 times as stiff as the wood. So there's basically two flavors here. There's metal and there's composite, which really means graphite. All right. Now metal comes in. There's really only three really that I've ever seen. You see steel ones a lot. You're starting to see titanium ones occasionally. Stuart McDonald sells titanium truss rods. I have a couple, but I haven't tried them out yet. You could put aluminum in there. I haven't seen anybody do it, but you certainly could. There certainly could. You could make an argument for doing that. And graphite is just what you think it is. This little unidirectional graphite truss rods. They're really light and they're easy to glue. And so these are quite popular, especially now that graphite's gotten a lot cheaper. So adjustable, there's basically one distinction here at the first level is one-way and two-way. Okay, a one-way truss rod simply takes the belly out of the neck. It can add a crown. A two-way truss rod could either take a belly out of the neck or put a belly in the neck. Well, why would you want a two-way truss rod? Strings are always going to bend it one way. Well, if you're not sure about atmospheric conditions, there's all kinds of reasons why a neck might bend in ways you didn't normally expect. And if you're like me, if you're teaching brand new guitar makers, well, sometimes you get some necks that maybe aren't as straight as you'd like, and it's nice to have the extra leeway to be able to either add a bow or take a bow out. So one way, there's two possibilities now. There's called a channel truss rod, and there's a tension rod. These are by far the most popular. You see these a lot because these are really simple and they're also really light. And then two-way truss rods, there's really only about one or two designs out there right now. So this is the big picture. When you understand this, you've got a pretty clear understanding of what design choices are available to you. So let's start over here. Fixed rod, we've already done that. Metal, graphite, we're good to go there. Now adjustable. What's an adjustable truss rod look like? There's a one-way truss rod is basically just a steel rod with threads on both ends. Since I've got this here, I think I can erase this now. If you need to go back later and look at this, just back the video up. Let's do one-way truss rods. Okay, these are called tension rods, and what they are is if this is the neck of the guitar, and I'm going to draw this really big and I'm going to draw it kind of conceptual here. Let's put this here. There's a rod that goes, and it isn't straight, it goes in a shallow U, I guess, and it's fixed on this end. There's a big fixed nut on one end that's buried in the neck, and on this end there's an adjustable nut. Okay? Now when you tighten this up, there's a net force that way. When that happens, it tends to bow the neck up like that, right? Now these are simple, they're cheap, and they're light. Okay, so they get used a lot. Most production guitars, as far as I know, I don't know that I've seen a whole lot that don't have this. The only problem with putting this in is how do you cut that slot? Well, there's guitar makers everywhere have got cool fixtures to do this. I've seen ones where you could cut that slot on a table saw, actually cut the curved slot. Another way to do it is just cut the slot flat bottom and then cut two pieces to slide into the slot, one like this and one like that. Glue them in that way, and that's pretty easy to do. Fender uses this a lot, Taylor uses this a lot, Gibson uses this a lot. These are a very, very popular way of solving the neck problem. But they're only one way. They can only push up. They can't push down, right? So that's a one-way truss rod. In case you're wondering what a one-way truss rod looks like before you install it. I found a picture here for you so you can see what it looks like. Okay, so let's see what a two-way truss rod looks like. I have these in my guitar lab here. So here's a couple of them like this. You can see they're small, you know, they have to fit into a neck. And so here's one flavor, and this is a low, what they call a low profile truss rod. Looks kind of like that. It's got round tubing on the steel rod on the bottom. That blue stuff is just a piece of plastic that is fitted over it. And then there's a rectangular bar welded on this end and welded on that end. A lot of times this will have a long piece of heat shrink plastic over it, so you don't actually see the two different pieces. Okay, and this one's sized for an electric guitar neck, I believe. This is a different one. This is a Stuart McDonald hot rod. I use these a lot. These work really well too. And it's made out of two round pieces of steel rod threaded on both ends, and they've got a brass block on both ends, and the adjusting nut sticks out there. Okay, that's what that looks like. If you want to know how one of these goes into a neck, here's a store-bought neck. This one, I think this might be from Mighty Mite. No, this is from somebody else. I'm not sure who made this, but this is a generic guitar neck. This is on for a Fender style guitar, and this is a replacement neck. If you decide you don't like the neck on your guitar, you can buy this. And this headstock here is a paddle, so you can cut it to whatever shape you want. Remember I told you about the skunk stripe? There's one right there. That's what a skunk stripe looks like. So this one has, I don't know what that is. Looks like it might be walnut or something on the back, and I don't know, walnut, rosewood, whatever that is on the front. But you can see that hole right there. Okay, that's the end of a tension rod, and this hole is lined with a black plastic tubing, so it looks kind of cool. And if you look, you can, I don't know if you can see it on the video, but there's a little hexagonal sunk nut in there, so you can put a Allen wrench in there and change the tension. And what that'll do is that'll bow the middle of the neck up. There's a neck that hasn't been put together yet. This is from a kit produced at Sinclair Community College by the guitarbuilding.org. If you want to go to their website there, you can see this kind of thing. Same kind of deal. This is for our students. This is a kit that we produce through a project I'm on. Tom Singer from Sinclair Community College runs the project. Real good guy. And there's the paddle neck again. You can see it's been cut out of a larger board. And there's this slot right there. Right? That's cut right in when the neck is milled on the CNC, and it fits one of these. So you just drop that in there like that. Okay, you can see the whole thing. So to adjust this one, you go in from the back. So you have to either cut a little pocket in the body of the guitar to reach in there, or you can take the neck out, adjust it, and screw it back in. It's really easy. Necks on electric guitars are oftentimes, at least in the Fender style, are held in with 4 sheet metal screws, number 8 sheet metal screws, affixed to that plate. So you just loosen that up, and that neck will come loose, and you can make the adjustment from that end if you want. Now this goes in here, and it can also go in. Some necks are built so that the adjusting nut is at the other end, like that one you just saw. You see this a lot too, so that you can adjust the neck without having to remove it from the guitar or without having to modify the body. So that's how that goes in, and then the fretboard just glues on over this. Okay, so it's if you're careful, sometimes you can glue the fretboard on and still pull the thing out from the end. Sometimes you can't do that, but that's how that works. Okay, so last thing is, how does a truss rod work? Well, we saw how the one-way truss rod work. How does a two-way truss rod work? Well, the way this thing is put together, there is a fixed, what I'm going to talk about here is this, the low-profile ones. These are probably the most popular style of truss rod right now. They're available at a lot of supply places, and they seem to be showing up a lot on kits and I assume production guitars. Okay, so there's a rectangular bar at the top. Okay, with a rounded rod at the bottom, and these are welded together at the end. I don't know if I can see this on the video, but there's, I can get that close enough that it'll focus. There we go. There's what it looks like at one end, and here's what it looks like at the other end. So it's welded together at this end. Okay, so this is a rectangular bar. It doesn't have to be rectangular, but if you make it rectangular, you make it low profile, you don't have to cut as deep a pocket into the neck. These are easy to install. You just drop them in. And this is a round rod. All right, and at this end, there's a, make sure I do this right, there's another block, and it's welded there, but this is threaded, and then your adjustment nut is at this end. So you got two choices. If you turn the rod one way and try to compress, and let's see the way this works, this is, oops, the bar, or the rod here, make sure I do this right, this block is welded on, but it's also threaded at that end. I guess I should have pointed that out. And they're probably threaded opposite directions now that I think about it. Yeah, they're threaded opposite directions. So right hand threads on one end, left hand threads on the other. So when you turn this one way, it tries to bring these two blocks together. When it does, this bends up. You turn it the other direction, it tries to force the two blocks apart, and it bends down. That's how a two-way truss rod works. So whatever two-way truss rod you're thinking about, they were looking at, they work approximately like this. There are lots of variations on this theme. Now the only other one is a channel rod I haven't talked about yet. These are a little more arcane. I've seen them on, I think Martin used them. They're around, and they're not too common, but they are popular. What you do is, if you look at it from the end, there's usually an aluminum U channel right here. Okay, if you look at it from the end, I'm looking down the end of the truss rod. Now that would be looking down this way, looking down the neck. And there is a round rod in there. And if you look, it's fixed on one end, there's a nut on the other. So when you look at them from the side, they look like this. There's a big plate on one end, or some nut or something, and there's a rod that goes down, and a washer or something on that, and your adjusting nut is right there. The elastic axis of that round rod is right there. The elastic axis of this U channel or C channel is right there. If I squeeze with this, I'm squeezing below the elastic axis of this U channel, and the U channel will bend up like that. Now I can't pull on I can't make a tension in the bar with this. I can only compress. That's why this is a one-way truss rod and not a two-way truss rod. So let's stop there. So we know guitar necks, all of them, almost, have truss rods in them. I should say that classical guitars sometimes don't, or if they do, it's almost always something fixed. You'll actually see, traditionally, people will put ebony wood reinforcement rods down the neck of classical guitars sometimes. Some classical guitars don't have anything in the neck, but they typically do not have adjustable truss rods. So basically, steel string guitars are much more likely to have truss rods, but they do have them. It does two things. It stiffens the neck and allows adjustment. If you have an adjustable truss rod, it allows adjustment. And there's two kinds of adjustable truss rods. There's two-way and one-way. Manufacturers tend to use one-way adjustable truss rods. Builders, like me, tend to use two-way truss rods because we like the flexibility that it gives us. So there you are. I hope that helps, and I'll see you next time.